Alright, this is it folks. We're finally gonna get to see some lights come on for the Millennium Falcon. I'm soldering some pins onto a Power Boost 500C. That's the power module that's gonna sit inside of the base of the Millennium Falcon trophy. The two pins in the corner that I'm connecting to that white and gray wire are a 5V and ground pin. The white and gray jumper wires are there only for testing purposes. For now, I'm bypassing the ventral hull's power port and connecting the power boost directly to the V plus and ground pins on the LED driver. When I connect the YT-1300, it should also receive power, and I should see a green LED on both the driver board and the YT-1300. This means both boards are receiving current from the power boost. I'll connect the two wires for the radar dish, and if the firmware's already been flashed to the YT-1300, when I power the entire thing up, I should be able to see the engines glow. The engine LEDs are not controlled by switches. I also want to make sure that the radar dish button actually changes the fiber optic firing arc indicators. I also still haven't wired up the switch for the headlight selector. To test it, I'll have to use a screwdriver on the socket that connects the headlight switch. Bridging the forward two pins should allow the central headlight to come on. Bridging the back two pins should allow the fiber optic headlights and the mandibles to come on. Now it's time to connect the ventral hull. I decided that the lines coming from the power connector were too long. The excess wire may have prevented the Falcon from closing, so I went ahead and trimmed them off and crimped on new connectors. Then I inserted the two wires into a 3-pin housing. That's because there's an unused pin between the V plus and ground pins on the LED driver. Next, I need to make a 3-pin JST male connector for the headlight switch. This cable will plug into the female JST connector where all of the headlight grounds are soldered. Now it's standard operating procedure. Tin all the tips on the switch, tin all the tips on the wires, add some heat shrink tubing, and then solder it all and shrink it all together. Out comes the Dremel, and I remove a little bit more plastic so that the fiber optics have some space to run. Plugging in this JST header can be a little bit tricky when there's all this extra stuff in the way, so these angle pliers are really helpful. I can also power the entire device using USB since it doesn't really draw that much current. That's how I'll test to see that my headlight switch works. The forward position should light the central headlight. Flipping the switch to the back position should light the fiber optic headlights. Just make sure that you don't have the power boost and the USB plugged in at the same time, otherwise you might fry your USB port on your computer. I'll plug in the power connector, making extra sure that the red wire goes to the V plus pin and the black wire goes to the ground pin. You do not want to reverse the current. Finally, I can do a test squishing. This is where I see if the model can close up without me breaking anything. If all goes well, that means that I can apply glue to the model. Since the electronics work, I can glue the Falcon shut. I'll leave the power connected during the process just to make sure I don't accidentally sever any of the connections. For the adhesives, I'm using both silicone glue as well as Gorilla Glue gel, which is a cyanoacrylate. The silicone glue is good for anything that's going to be close to any of the LED lenses or the fiber optics. On the engine grille, I'm using a heavy layer of silicone glue to make a diffuser for the LEDs. I'm using silicone glue because the fumes from cyanoacrylate can cloud the plastic LEDs. However, the Gorilla Glue gel can be used on any of the other plastic pieces and the back half of the Falcon. In fact, you need the strength of superglue to keep the back half of the Falcon closed because of all of the electronics inside that are pushing the two halves apart. It doesn't take too long to dry, so you can be patient. Now I have to glue together the mandibles. I wanted to do these independently because you need to be very careful with Gorilla Glue gel. It can actually melt through the fiber optic plastic, and then you're going to have to start over. I can apply a small dab of Gorilla Glue gel to the outside of the mandible away from the fiber optics, and spread it with a little piece of wire. Before sealing the mandible and allowing the Gorilla Glue to cure, I'm injecting a little bit of silicone glue directly onto the fiber optics. This will prevent the fibers from backing out of the headlight. After pressing it closed, I'm going to use a little bit of paper to wipe it clean and then wait for it to dry. Now I can repeat the process with the other mandible, except for one small change. This is the mandible that I broke in the first video. So, I'm applying silicone glue directly into the gap and then attaching that broken piece onto the silicone glue. Remember that I can't use Gorilla Glue gel anywhere near the fiber optics, otherwise they'll break. I cannot stress this point to you enough. Now I can trim down the fiber optics most of the way. I'm leaving a few millimeters because there's going to be a paint job that's going to go onto this Falcon. After the paint is applied, I'll trim off the remainder of the fiber optics to make sure that the ends are not obscured. The radar dish firing arc indicator switch still works, and I can switch the headlights from the central headlight to the forward headlights in the mandibles. That's it for the main model. In the next video, I'm working on the escape craft. I'll be adding a fiber optic cable that runs through the escape craft so that the central LED can illuminate the headlight when the escape craft is docked. Thanks for watching!